Hello, everyone. Thank you for attending today's webinar and taking the time out of your busy schedules. We have a lot of material to cover today, but please keep asking questions in the chat window like Bowen said. So we'll talk about Amazon CloudFront today and how you can use CloudFront, which is AWS's content delivery service, to accelerate your static, dynamic, and interactive content, essentially all different types of content that you may have on your web application. So, the first slide I have here is you may be wondering, well, why is this even there? Why performance matters? I think most of us get it, but I still think it's good to set the context and here that performance is important because performance translates to higher page views, performance directly impacts your customer experience, and leads to higher conversion rates. And these are all business metrics that we all care about when it comes to having a user-facing web application. To put a little bit more data to that, if you look at this slide over here, there was a study done by Aberdeen Group which shows that for an e-commerce site that makes $100,000 a day in revenue, a 1-second delay in page load time can result in a loss of $2.5 million in sales over the course of the year. And these are big numbers, and you can also see the loss in conversions, page views, as well as customer satisfaction. So this is why we think performance is important, and we all care about performance, and would love to share a lot of tips with you today on how you can use Amazon CloudFront to improve performance. So when you think about performance, and when I see customers and where they're spending their time, a lot of time is spent in improving backend infrastructure performance, whether that's your database and making that as fast as possible, whether that's your application tier or your web tier. But 80% of a user's perceived latency really comes from the front end. It's the HTML, it's the objects that they download from your application. That's where the latency over the network when they are trying to download your HTML on your application or your website from a web server. That's where the slowness comes into factor. So how do we tackle that? How can we think about improving the performance of a web application that you may have? Well, a typical application has two different types of content, and this is just to simplify the world. Of course, web applications are complicated these days, but if you think about it at the highest level, there's static or reusable content, and there's dynamic or interactive content. For static content, you can either set high TTLs so that the content can live in a cache for a long period of time, or you can set low TTLs if the content is updated frequently. And then dynamic or interactive content really cannot be cached, so you have to set a 0 TTL there, but we'll walk through some examples of how you can improve performance of dynamic content as well using Amazon CloudFront. So here are some examples of static or reusable content. You see images, your style sheets, JavaScript files, and then on the right you see a screen grab of the Amazon.com website where you see related products. So users who viewed this book also viewed these other books. This is customized content on the Amazon.com website. And you would think that, okay, this is personalized to a set of users, so it couldn't really be cached. But we'll see how even this content can be cached at the CDN edge nodes. But typically, when I talk to customers, they use an architecture that looks something like this. Well, to deliver their web application, they have their static content, which is sitting in an Amazon S3 bucket or their own origin servers, being fronted by a CDN. Amazon CloudFront with the cdn.example.com domain. But their dynamic content, users are going directly to the origin servers to download the dynamic content. So the reason customers do this, and what they say is, well, my dynamic content cannot be cached. That's right. So, so the response I get is, why cache my dynamic content or why use a CDN for my dynamic content? The argument there is dynamic content, for example, your HTML pages, affect 100% of your viewers. So all your viewers, the first thing they need to do is download your HTML before the page can start rendering on the browser, and the browser can start downloading the static assets on that page. So it's important to optimize the performance of your dynamic content to the extent possible. So why not use an architecture that looks something like this, where the CloudFront CDN node can front both your static and your dynamic content. So users can go to CloudFront first using a single domain name, www.example.com, to download both the dynamic and the static content. The static content may be cached for a long or a short period of time at the edge node, and the dynamic content is probably not cached. It has a 0 TTL and gets simply proxied via the edge node. So when we ask customers, so why not have an architecture like that? Why not put CloudFront in front of your dynamic content or a CDN in front of your dynamic content? Customers typically say some combination of these statements. Either, I don't see the value. Each request is unique and must go back to the origin server. Or customers say, well, I see the value, I understand the technical details here, but my current CDN charges me premium rates for dynamic content acceleration with so many additional fees that it's too expensive for me to utilize this technology. Or customers are often frustrated with how difficult it is to configure their current CDN for dynamic content acceleration. They say that it requires expensive professional services and it's not self-service. So how can Amazon CloudFront help? And this is really, think of this as the agenda slide for our session today, where we'll talk about several different techniques and technologies that Amazon CloudFront has implemented that can help speed up the delivery of both your static and dynamic content. And I want to especially highlight the last point there, which is CloudFront pricing for static content is the same as dynamic content. So we don't differentiate between static and dynamic content in terms of pricing. They're both priced at the same low rates, the pay-as-you-go pricing that's available on the website. So let's dive right in. So going back to our two types of content that we talked about, unique or reusable content. What are these? Unique or reusable content is an object that does not change for a given period of time. It's something that you can cache and deliver the exact same object over and over again to multiple users who are requesting it. And then dynamic or interactive content is the opposite of that, where the content changes as soon as it gets created. So this is personalized to a particular user, and caching does not provide any benefit because you can't reuse it, you can't deliver it again to another user. So let's look at an example website here. This is an e-commerce website, a bookstore. And for this website, this website has both dynamic and static content. The dynamic content, as I've pointed out here, is the index.jsp, is the HTML page, just to keep things simple. That's the dynamic part of this site. And then the images that you see, the product images on the page, are examples of static content. Now, this particular page takes 1.5 seconds currently to download for a user. And going back to our statistic that we saw from Aberdeen Group, the 1.5 seconds, if we could lower that to 0.5 seconds or reduce the download time of this page by a second, this particular e-commerce website could be earning $2.5 million more in a year in sales. So let's see if we can do that. How can we improve the performance of this particular web application? Well, we can accelerate the static content on that application, and we can accelerate the dynamic content that's there on this application. So I would assume a lot of you are familiar with waterfall graphs. Every major browser shows the waterfall graphs where you can see for every object that the browser downloads, including your base index.html page, you see the amount of time that was taken to download each of those objects. And for each object, the time bar is also broken up into things like DNS lookup, the TCP connection time, time to first byte, and the content download time itself. So you see here that the top bar here is for the index.jsp for our example e-commerce website. And then the bars down below are for each of the individual objects that the browser needs to download from the server for this particular website. So let's go about and first optimize the static content that's on their site and see what performance improvement that can provide to us. So again, on this waterfall graph, you see the static contents are the smaller bars down below the first longer bar, and these are things like images or music or video files or text objects, your JavaScript, your CSS. So static content is something that by definition does not change quickly, and we can distribute that to more than one user. So how long can you cache your static content? You could cache it for a few seconds, a few minutes, hours, days. And caching is a way to serve that content to more than one user so that your request doesn't need to go all the way back to your web server. So let's look at an example here. So there's a user request A from this computer who's making seems to be a little bit of trouble here. Okay. This user is requesting an image from the edge location. And the edge location doesn't have this image today, so the edge location sends a request back to the origin server. The origin server responds back to the edge location, and the edge location can now cache this object. You see a red dot at the edge location. And then the edge location responds back to the user with the object, and the user has downloaded this object now. The next user request B, that comes to the same edge location for that same object before the object has expired because it's cached over there. The edge location does not need to go back to the origin this time. It can just respond back to the browser with that image or with that object. So that's the benefit that caching your static objects across the globe using a CDN like Amazon CloudFront provides, because CloudFront edge nodes that are distributed around the world, and today we have 46 nodes around the world, you bring your content closer to your users, so your users don't have to go all the way back to your origin servers. So optimizing static content, you use caching, and that helps improve the experience and the performance for your users. It helps offload your infrastructure as well, because the requests are not making all the way back to the origin, or at least not all requests are making back to the origin. So that relieves load on your origin servers. So looking at our example web application again, before caching the static objects that were on that page, we said that the page took about 1.5 seconds or 1.46 seconds in this case to load. After we cached all of the static content, we noticed that the load time for the entire page goes down basically in half. So 770 milliseconds now. So that's a huge improvement. The page is loading much faster. So are we really done? We have cached all of our static content. Well, not so fast. So let's look at our waterfall graph again. What we have done so far is we've taken some of our static objects, such as the JavaScript, the CSS, and the images, and cached them at the CloudFront edge nodes. Great, that helped bring down the page load time significantly. But what about some other types of static content or reusable contents that may be there on that page, as well as our index.jsp? We haven't really touched those objects yet at all. So the overall goal here should be, as you're looking at your web application, even beyond the static objects, is to cache as much as you can, cache as much as possible, to identify objects, to identify resources on your application that impact user download time and performance, and figure out ways in which you could cache it at the edge nodes. So, you may ask, well, I'm already caching my images, my CSS, my JavaScript. What else can I cache? So there, I would I would say, I would give you one approach. You can find other approaches in terms of how you can identify objects on your application that you can cache. But one of the approaches could be, well, collect your web application logs from your web tier. These are generally W3C compliant standardized logs, and you can run a log analysis tool or run a report using either an AWS service such as EMR, which is our Elastic MapReduce service, or RDS, which is our relational database store, or Redshift, and you can identify the top N URLs that your users are requesting. So running that analysis for our example website, we see 220 users are requesting the index.jsp, 200 requesting the book1.gif image, and so on. So we have already cached the GIF, which is the image, the CSS file, which is the cascading style sheet, and the JavaScript file for this page. But you see there's a lot of other URLs that have been requested fairly frequently in this short period of time that we did the log analysis for that we haven't really thought about caching. So let's see if we could potentially cache some of those URLs as well. So what about content that is delivered via query strings? Could be search results, for instance. So in this example, this particular URL that has a query string was requested 110 times. So do we think this content could be cached? Maybe it's reusable? Possibly. CloudFront can cache content with query strings as well. So every unique query string combination is a new object in CloudFront's cache. So the query string parameter in the URL, name equals or search equals whatever the user is searching on. If you find in your web tier logs that a particular query string URL is requested multiple times, then you can actually cache that URL. What about API calls? So if you have APIs that you're delivering and then that your viewers are using, so in this example, category equals math, so this API result will respond back with all of the math books, or the books that are categorized under the math category. 100 customers call this API, or 100 users. So is this reusable? What about another API call that lists the top 10 books on that example website? Is that reusable? We saw 80 requests for that particular API result. So when you think about API calls, for instance, then you may think that, well, my API results are actually database driven. They're changing fairly frequently, although not necessarily every request, but they're changing maybe every 5 seconds or 10 seconds as my database is continuously updating the results on the back end. Well, I couldn't really cache it, or I may not get the benefit from caching it. So there, what I would suggest is, hey, what if we changed our time unit? Because content can be cached at CloudFront Edge locations, not just for hours, not just for minutes, but also for seconds. So CloudFront can cache your content for any unit of time, including really small units of time. So if a particular API call gets 1,000 hits, so if you have a read-heavy API, for instance, you can offload your web tier from handling those 1,000 requests per second. You can also offload your load balancers, whether it's your Elastic load balancer, ELB, or any other load balancer that you may be using, and let the CloudFront Edge location handle all of those requests per second, all of those requests from the users. This, again, helps you provision less capacity and helps you reduce your costs at the origin server, so you don't have to provision as many load balancers or web tier servers. So now let's say we have identified a short period of time that we can cache our query strings and our API calls. We've already cached our images, JavaScript, and CSS files. We're finally left with our base page, our HTML page, which is the index.jsp. Well, 220 users requested this. Basically, this impacts everyone, and the requests are going all the way back to the origin server. Can we potentially cache this? Typically not. It depends, but typically not. So in our example, for instance, this is an example of dynamic content, because in this example, this web page was customized or personalized to me. It said, hello, Nihar, because I'm logged in. So this is an example of dynamic content, and let's talk about how using a CloudFront Edge node and proxying the request for this particular page through that CloudFront Edge node can help improve the performance even further. for this e-commerce website. So let's focus on our index.jsp page and the waterfall graph. And our goal is to really compress that particular waterfall graph to the extent we can. Now, dynamic content is not cacheable. We can't really cache that at the edge, at least in this example, but we can proxy that request to the origin and back from the origin via the CloudFront Edge node. So let's look at an example here. The first user sends a request for dynamic content to an edge location. The edge location doesn't have this content because it's not cacheable, so the edge location sends the request back to the origin. The origin responds back, and the origin sends the response, and the edge sends the response back to the user. The origin instructs the edge location to not cache this, so the edge location doesn't have this particular object in its cache. So when the second user makes a request for the same object, the edge location sends the request back to the origin again. The origin responds back to the edge, and then the edge will deliver that particular object to the user. So as you can see, this basically demonstrates that every request is going all the way back to the origin server. So wouldn't that add latency? That's a question that I get sometimes from customers, because you're adding another hop along the way. You're adding a CloudFront Edge node that must proxy this request back to the origin server versus this user of mine going directly to the origin server. So how can CloudFront help optimize this dynamic content delivery by putting CloudFront in the middle of a user and the origin server for a dynamic request? So our goal, again, is to compress this particular waterfall chart for our index.jsp page. So let's look at it piece by piece. What does this waterfall chart, or what does this download time compose of? This is composed of the DNS lookup time, the TCP connection time, time to first byte, and the content download time. So how do we optimize and how do we compress each one of those bars, each one of those portions of that bar? So for reduced DNS time, we can use Route 53, which is Amazon's authoritative DNS service. For reduced connection time, we can take advantage of CloudFront's Keep Alive connections back to the origin servers from every edge node. For reduced first byte time, we can again take advantage of CloudFront's Keep Alive connections. And then for the content download time, even though we're not caching the content at the edge, we can take advantage of CloudFront's TCP IP optimizations to download that content faster when proxied via CloudFront Edge location. So let's use this as a reference again before we dive into optimizing our dynamic content. Before any dynamic content optimization, we were at 770 milliseconds for downloading this page. So how do we first improve our DNS time? Well, with Amazon Route 53, which is AWS's authoritative DNS service, you can get low latency DNS resolution. And that's because of the global network of DNS servers that Amazon Route 53 uses that are distributed across the world, to making Route 53 fast, easy to use, and a cost-effective authoritative DNS service. The queries from your end users are routed to the nearest DNS server, and that DNS server responds back in a very short period of time versus that query going to one central DNS server or a couple of DNS servers that you may be running. So let's look at this in this example. This may be a typical or traditional architecture where you've got a couple of DNS servers running, one in the US, one maybe in Europe, and these two are serving your entire global user base when resolving DNS queries. But instead, Route 53 has multiple DNS servers or multiple nodes that are running across the world, and your users get routed to the closest DNS server that can answer their query. How about the TCP connection time and the time to first byte? Let's focus on those. So we talked about using Amazon CloudFront's Keep Alive connections and how that can help you lower your TCP connect time. So what are the TCP IP bottlenecks on the internet? Many of you are familiar with this. if you think about dynamic content is typically small in size. We're talking about the shell of your web page is the HTML. And HTTP, which runs on TCP/IP, gets penalized for objects that are small in size, your dynamic content, because there's a lot of time spent on establishing a TCP connection relative to the time that's required to download that relatively small, a few kilobyte size object. The connection time really is, what's involved there is when TCP initiates a handshake from the client to another server, it does a SYN, a SYN-ACK, and an ACK, so there's a three-way handshake. So there's a round trip that happens before the client can even request the data that it needs to be downloaded. So first, the connection needs to be established, and then you can send the request for the data. So this handshake delay, it depends on the client-to-server latency, because the round trip needs to traverse the entire distance from the browser to the server and come back. So let's look at an example here. A TCP handshake starts with a SYN. In response, the client receives a SYN-ACK, and then the client responds back with an ACK, and then requests the data. So that's the length of time that takes for the entire TCP handshake to occur. So if your users today are not using CloudFront for dynamic content, so you have multiple users across the world, each of your users get connected to your infrastructure directly because there is no CloudFront proxy in the middle. Every user causes a new TCP connection at your origin infrastructure because every client browser must do that TCP handshake first before requesting data. So the more users you have, the more TCP connections you need to establish with your origin infrastructure. And you're not leveraging the keep alive connections potentially that you could get from directing those users to a proxy like a CloudFront Edge node, which could keep the connections alive, and your origin servers wouldn't need to do TCP handshakes all the time to serve all of your different viewers. So looking at it in this particular diagram, you see that all of these different users are connecting directly with the Elastic Load Balancer, and they're all initiating TCP connections individually with the load balancer. Just having a little technical issue here on my end. I think you are able to see the slides. All right, so without the keep alive connections, if all of your users are connecting directly to the load balancer to your origin infrastructure, that puts load on your web servers. That causes an increase in your memory, in your CPU utilization, and without the keep alive connections, this load on your web server increases the time to first byte that your users can see. So the longer your web tier takes to respond back to the user's requests with the data that they want to download, that increases the time that it takes the user to be able to see the data that they requested. So it just increases the time to first byte, and that lowers performance. So how do keep alive connections help? Well, keep alive connections, they help you avoid additional connections. So not all of your users need to establish a TCP connection directly with the origin server. So there are fewer handshakes as a result, and that helps improve the TCP connect time and the time to first byte. So CloudFront utilizes keep alive connections from each edge node back to the origin server. So your users will get connected to one of CloudFront's 46 nodes. CloudFront opens a keep alive connection back to your web tier. CloudFront keeps that connection open so that when we receive a request from another user of yours for another object on your site, or maybe the same object, we use the same connection that's kept alive back to your web tier, to your origin infrastructure. We don't need to establish a new TCP connection from CloudFront Edge node back to the origin. So we reuse the existing connection and directly go and ask for the data. So with CloudFront, more users does not equal more TCP connections. Again, that's because of reusing existing connections that are already established from other users who came prior to the current user. That helps improve response time due to fewer TCP handshakes, and that helps also offload your web tier's CPU and memory utilization. So let's look at another diagram here where your users are going to, your first user goes to a CloudFront Edge node. CloudFront Edge node establishes or does a TCP handshake because this is the first time the Edge node is going back to the origin server. It keeps that connection alive. So when the second user comes to CloudFront requesting content, or the third user comes, that same connection that's already kept open with the origin server is utilized to download that dynamic content. So we did a little bit of testing with this, and what we saw is when we sent a number of requests to, so this was a lab test. When we sent a large number of requests to CloudFront Edge location, and because the CloudFront Edge location was keeping connections alive with the origin server, the CPU utilization at the origin web server with CloudFront and the keep alive connections was 6%, which was significantly below when there was no CloudFront, and all of those requests were going directly to the origin server, with each request causing a TCP handshake and a connection and establishing a connection. So that's some significant savings there in terms of your CPU utilization. So you don't have to scale your origin infrastructure as much as you would if there were no CloudFront. So now let's get to the content download time and how can we optimize the content download time and compress that further for our dynamic content where every request has to go back to the origin. So this is where you can take advantage of CloudFront's TCP IP slow start optimization. So what does that mean? TCP slow start, this is a concept that's out on the internet, and it's there because we need to control the amount of data that's exchanged between two hosts. So the TCP handshake, once that's established, the number of packets that can be sent between those two hosts start out small, and then they grow over time as the two hosts are talking to each other for a longer period of time. So slow start is really there out on the internet to avoid overwhelming the internet so that not the entire megabytes of data can be sent in a single packet, and that may cause congestion on the pipes. So what does CloudFront do to help with slow start optimization? Well, CloudFront helps optimize slow start by advertising a larger initial congestion window so that more data can be sent in that initial request. And then also, since CloudFront keeps connections alive back to the origin server, that congestion window is actually optimized over time so that each new user that requests content off of CloudFront goes back to the origin server over an optimized connection where more data can be sent from the origin back to the CloudFront Edge node, versus if the client was going directly to the origin server and starting out at a small congestion window, a slow start, and then getting that optimized over time. So these are all techniques, the slow start optimization, the TCP IP optimizations that are already keep alive connections. These are all already existing in CloudFront for accelerating the delivery of your dynamic content. These are not configurations or knobs you need to tweak. You get the benefit of these optimizations simply by using CloudFront and setting the right time to live on your objects so that your requests can either be your objects can either be cached or proxied through a CloudFront Edge node. Now, we started off with the example of an e-commerce website. Without doubt, the e-commerce website will need to have some connections that would be over SSL, so secure connections. So how can we optimize those secure connections? With CloudFront, you can use CloudFront to terminate SSL at the edge location. So your users can connect to CloudFront over an SSL connection, and we'll see how that can benefit in terms of offloading load from your origin infrastructure. So with SSL optimization with CloudFront, you can use either the CloudFront certificate, the star.cloudfront.net certificate, or you can bring your own custom certificate and upload that to CloudFront and use that for your users to establish TCP connections. The SSL traffic gets terminated at the closest CloudFront edge location. And there are a couple of different patterns actually that I've seen customers use when it comes to using SSL with CloudFront. I call them a half-bridge SSL termination or a full-bridge SSL termination. So let's talk about what those mean. So in the half-bridge SSL termination, the client or the user connects to a CloudFront edge location over HTTPS, over an SSL connection. And then the CloudFront edge node goes back to your origin infrastructure over HTTP. So you can see here all of your users are going to the edge node via HTTPS. The connection gets terminated at the edge node, and then the edge node uses regular HTTP, which is less expensive from a computation perspective, to go back to your origin infrastructure. So your users get the encrypted channel and the advantage of terminating SSL closer to them, which helps improve performance for them, while the edge node is going back to your origin over HTTP. That helps bring your content back to the edge node faster. So better performance by leveraging HTTP connections back to the origin, and then also, since the SSL handshake is a lot more expensive than just a regular TCP handshake, your origin is actually offloaded by terminating SSL connections at the edge. And if you weren't using CloudFront, all of your users who need to use SSL would be terminating the SSL connections at your origin infrastructure, so your origin would need to scale further to be able to support all of those SSL terminations. So taking advantage of CloudFront Keep Alive connections, that's another benefit that you get even for SSL connections. CloudFront still keeps the connections open to your origin infrastructure, and all of the TCP IP optimizations and the window sizing that we talked about do apply for SSL connections as well. So how does that compare to the full bridge SSL termination? In this scenario, the users connect to a CloudFront edge node over HTTPS over an SSL connection, and then the edge node goes back to your origin infrastructure also over an SSL connection. So in this optimization, your users are connecting over HTTPS, and then the edge node is also going over HTTPS to your origin infrastructure, so you get the benefit of end-to-end encryption from the user all the way back to your origin server. And you're still getting the advantage of terminating the SSL connection from your users closer to them at a CloudFront edge node, so that they don't have to establish an SSL connection over a long haul, depending on where your users are, relative to your origin server. So a half-bridge, or rather this should be full bridge. Full bridge SSL termination also has the same benefits as the half-bridge. It's taking advantage of CloudFront Keep Alive connections, as well as all of the TCP IP optimizations apply here as well. Another type of content that your interactive or e-commerce type application may have is optimizing post or put. It's using post or put HTTP verbs or methods to actually upload content, whether that's filling out a form, a comment box, logging into your site, add to cart buttons, etc. This is actually a feature that we launched less than a month ago because our customers requested this feature. They wanted to use a single domain name for their entire website and accelerate their entire website, not just their static content, but also their dynamic content, their interactive content, and be able to use post, put, or other HTTP methods. So how does CloudFront help optimize post or put? With Amazon CloudFront's post-put verb optimization, CloudFront supports multiple upload verbs, so not just post-put, but also delete, options, and patch. So you can actually use CloudFront to deliver your RESTful APIs, and you can either cache the responses to the API calls, or you can just proxy them and take advantage of the keep alive connections and the TCP IP optimizations. With post-put, your data actually won't get cached. It's simply a proxy through a CloudFront edge node back to your origin infrastructure. And all of the dynamic content optimizations do apply, though, which is keep alive connections, TCP slow start, as well as terminating the post-put connections closer to the viewers, the TCP connections, using a CloudFront edge location nearby them. So some examples of where you would use post-put optimizations with CloudFront. You can optimize your form posts. So when your users are submitting a form on your website, you can optimize your AJAX post requests on your application. You can even have your users upload content, for example, to your S3 bucket via CloudFront edge node by doing a post or a put. So going back to our waterfall chart for our example website or web application, after utilizing CloudFront for dynamic content optimization, we're down from 770 milliseconds to 555 milliseconds for downloading this entire page, including the index.jsp. Now we're much closer to reducing our page download time by 1 second, which can help us get that $2.5 million in sales a year on that e-commerce site. So we go from 1.5 seconds to 0.5 seconds in downloading this entire page by caching everything that's possible and also proxying the dynamic content via CloudFront edge node. So how can we improve the content download time even further? We can use Amazon Route 53's latency-based routing feature. So what latency-based routing does is, if you run multiple stacks of your application in different EC2 regions around the world, you can create latency-based routing or LBR records with Route 53 with the DNS service using the API or the console, and then tag each destination endpoint to that particular EC2 region, wherever your application is at. And the endpoints can either be EC2 instances, elastic IPs, or elastic load balancers. And what Route 53 will do is route your end users to the endpoint that provides the lowest latency. So the benefits that LBR with Route 53 provides is better performance than running in a single region. So you could be running an application stack in multiple regions across the world. You improve the reliability of your website relative to running in a single region. So it's beneficial from an availability perspective. Route 53 does provide a really simple and easy implementation than other DNS solutions, and significantly lower prices than other traditional DNS solutions for this particular feature. So how can CloudFront and Route 53 work together and take advantage, and you can take advantage of the latency-based routing feature that Route 53 offers? Well, you can use CloudFront for the dynamic content acceleration and host your origin servers at multiple AWS locations, for instance, in the US and in Europe, and then create DNS records in Route 53 for each of your origin locations, and then just let Route 53 handle which CloudFront edge node it wants to send to which of your origin locations based on where that edge node is located. So when CloudFront edge nodes is trying to get data from your origin server, those requests will be taking advantage of latency-based routing. So for instance, the edge nodes that are closer to your origin infrastructure in Europe will go to the Europe origin location, and the CloudFront nodes that are closer to your origin in the US will go to the US origin location. So Route 53 does this by measuring the latency between CloudFront and all of the configured origin servers that you have, and resolves the origin hostname to that closest location for CloudFront when CloudFront is trying to fetch content from your origin server. And this can help further reduce the download time for your content, especially for dynamic content where the edge node must always go back to your origin servers to retrieve that content. So another quick example here, where if you have an AWS, if your origin server is running in an AWS region just in the US, your users connect to a CloudFront edge node, and CloudFront goes back to the origin server in the US. But if you have a user also in Europe, that user goes to a CloudFront edge node nearby, but that edge node must go back to that same origin server in the US because you have a single origin server currently. Now with two origin servers running in, for instance, US and Europe, the example we're using here, your users in the US will go to a CloudFront edge node in the US that's near them. That edge node will use Route 53 to resolve the DNS for your origin servers. Route 53 will respond back with the US location, but because this particular end user is in US, and then the edge node, the CloudFront edge node, will go to your origin infrastructure in the US. The exact same thing happens for the Europe location of your origin infrastructure. Your user in Europe goes to a CloudFront edge node close to them within Europe. That edge node talks to a Route 53 DNS server that says, hey, you are actually closer to the Europe location based on latency. So the edge node, as a result of Route 53's latency-based routing feature, ends up connecting to your origin infrastructure in Europe this time, instead of going all the way back to your origin in US. So I just wanted to take a second and summarize, because there's a lot of material that we covered in this deck. So I think the key takeaways from my perspective are, first, cache everything that you can. Your static content, your reusable content, including your query strings or anything that you're customizing using cookies. The task that you have at hand is identifying how long that content can be cached, whether that's hours or minutes or seconds. But to the extent that you can cache all of your highly and frequently requested URLs, the more advantageous it'll be, because you will be able to serve them locally from an edge location close to your viewers. Second, CloudFront can also help speed up your dynamic content, including your uploads with post and put optimization, a feature that we recently added. Third, SSL termination, when you're using SSL and your users terminating their SSL connections at the edge, that can help offload your origin infrastructure. And CloudFront does provide you the ability to use your custom domain name and assert that you can upload to CloudFront for SSL delivery using your own domain name. Fourth, Route 53's latency-based routing can improve performance further if you can run multiple stacks of your application across the world in different regions, again, depending on where your users actually are located. And fifth, just want to reiterate that CloudFront is really easy to use, with all of our features available via API calls, so you can use them programmatically or via the management console. And the pricing for static and dynamic content is exactly the same. We don't charge premium prices for dynamic content. So I wanted to close out with a few customer examples to provide, to give you some stories of how different customers are using some of the features that we discussed in the early part of the presentation. So the first example I have here is for low TTLs, and the customer here is Vox Media. Vox Media has a live blog on their The Verge website, and where in this live blog they cover live events, frequently in the tech industry as they're happening, and provide live blogging and updates to what's going on. This is a great use case where, even though this page is updated every few seconds, the Verge live blog gets a ton of traffic as the event is happening. So, for instance, I have the screenshot of the Amazon Kindle event here, and as more and more users come here, to the extent that Vox can cache this page at CloudFront Edge nodes, which is what they do. They put a really low TTL, and they're able to scale up to tens of thousands to potentially hundreds of thousands of users coming to this one page by taking advantage of caching at the edge node without overloading their origin infrastructure. So that's a great example of setting a low TTL for interactive and live content, and yet be able to not need to scale their origin infrastructure. Another example here is Toronto Star. This is the largest newspaper company in Canada, and their website, thestar.com, uses CloudFront to deliver all types of content, but in particular I wanted to call out how they use query strings to cache their search results URL. So you can see the URL in the screenshot that says thestar.com/search.html q equals Kindle. And this is a Kindle results page, so they can cache this page for a few seconds or a few minutes at a time, so that everyone searching on Kindle within that period of time will get the cached copy of that page, and those requests never make it back to their origin infrastructure. Another example of a customer, Earth Networks, they have the WeatherBug mobile desktop application, and they use cookies to customize the weather results for a particular zip code. So I have the screenshot of Las Vegas here, the weather data for them for that particular zip code, and the zip code data is stored in a cookie so that everyone in the Las Vegas area or everyone across the world who's requesting and wanting to see the weather within that, let's say, 5-minute period that this page is cached with that particular cookie will get the same cached copy of that page. So those requests never end up making back to the origin server. So that really helps offload the origin servers. So one of our newer features, post and put, Uyala, this is an interesting example where Uyala is one of our customers who's using CloudFront's new post, put, patch, and delete capabilities. And there's a quote here from Ilan, who's their tech lead on the site reliability engineering team, where Uyala is using CloudFront to accelerate their RESTful APIs that are running on Amazon EC2 by using CloudFront Edge nodes and proxying those requests back to their EC2 nodes. They are seeing lower packet loss and better upload latency as a result of this. And then the final customer story I wanted to leave you with is Mapbox. This is a customer that provides map tiles and a lot of large sites, for instance, Foursquare. They integrate their maps into their applications. And Mapbox, the number one requested feature that Mapbox had from their partners was to deliver these map tiles over SSL. So Mapbox is taking advantage of CloudFront and the SSL termination at the CloudFront Edge nodes to provide SSL functionality to the users of the applications where their maps are integrated. And then one last note, before we go into questions, we have the AWS reInvent conference next week in Las Vegas, and we have a few CloudFront related sessions at the conference. If you are there at the conference, please definitely stop by and try to attend one of these sessions. At this point, we'll go to questions. We only have a few minutes left. I'll try to answer as many questions as I can right now. Otherwise, we'll respond back to your questions via email.
Thanks, Nihar. So yeah, we've had a lot of great questions, and I think I want to say, just based on these questions, we'll probably want to do schedule a office hours. So look for that after reInvent. So we'll be able to answer more in-depth questions. One-on-one, our attendance for those is a lot lower, so you'll be able to get your questions answered. So one of the questions, is there an error on the page? If there is an error on the page that's already been cached by CloudFront, how can we force an update on the cached files?
Sure. So if a page is already being cached by CloudFront, there's a couple of different options. One, you can, of course, wait for the page to expire in the CloudFront cache. But since you want to force an update, and let's say the page was set to cache for a long period of time, CloudFront does provide an invalidation API. So you can actually request that particular page to be invalidated And when you use that API call, or you can use the console and give us the URL of that page, we will go out and delete that page, the cached copy of that page from all the different edge nodes across the world.
Also, we have a question about how people can see a list of our edge locations.
Yeah, so as I mentioned, we have 46 edge locations today, and the list of all of our edge locations is available on our website. So if you just go to aws.amazon.com/CloudFront, you'll be able to see a list of all of our edge locations over there, and a lot of great information on that page also about our different features, a developer guide that you can use to learn more about using CloudFront, as well as our pricing is available there on that page. In addition to the on-demand pricing that we have on that page, we also have private pricing available for customers who have predictable demands and are able to make a commitment, and you can contact us via that page.
This is a kind of a high-level question about using S3 versus CloudFront, and if you could briefly explain what the difference is. Using S3 versus CloudFront for content delivery.
Got it. So when it comes to S3 versus CloudFront, CloudFront gives you a global infrastructure of servers where your content can be cached much closer to your viewers. S3, on the other hand, is a great storage service where you can actually store your data for high availability and high durability. But S3, delivering content directly out of S3, while possible, if your users are spread across the world, they will all be going back to a single S3 location where your data lives to request that data. So in terms of the TCP connections and in terms of just network latency, so let's say your S3 bucket is in the east coast of the U.S., in our U.S. East region, and if your user is all the way in Singapore, they're now going all the way across a couple of oceans to the S3 bucket to request to download that object, versus they could be going to the CloudFront Edge location near them in Singapore and downloading it directly from there if the content is cached there.
Can an existing application, this will be the last question just given the time, but can an existing application benefit from this optimization scenario, or should it be modified, rewritten?
So that's a great question, actually, and your existing applications can most certainly benefit from using CloudFront and all of the optimizations CloudFront provides. So CloudFront has the ability to talk to multiple origin servers. So if your application today uses S3 for storage of your static content and ELB or an EC2 instance for the dynamic content, you can configure CloudFront to go to the different origin servers based on the URL path or based on the type of content using our cache behaviors feature. And without modifying your backend infrastructure, CloudFront will go to different resources or different locations for different types of object and deliver them to the users who are requesting that particular content from CloudFront. So you can use a single domain name for your website, www.example.com, point that domain name and point your users to a CloudFront Edge node, and then configure the CloudFront distribution so that the Edge node is smart and knows where to go for what type of content. So you don't need to change your existing infrastructure. You can just use our cache behaviors feature and take advantage of all the CloudFront optimizations.
Okay. Thank you, Nihar. I'm going to turn it back over to Bowen.
Great. I'd like to extend a special thank you to our presenter, Nihar, for his time and a great presentation.